Domain-driven design, also known as DDD, is a software development technique that concentrates on the domain model and domain logic. As Eric Evans puts it in his book, Domain-Driven Design: Tackling Complexity in the Heart of Software, the structure and language of our code should match that of the business domain. This concept is called the ubiquitous language. Fundamentally, DDD is about creating a language that connects the implementation to the business experts and their knowledge. So essentially, words and phrases from the domain are directly used in the codebase. Therefore, we can use this language to construct a rich model for our domain, describing all of the objects and interactions between them using a language that is understood by both the business experts and the developers. For this, we can follow the strategic design process that may include several tools and techniques such as domain storytelling, event storming, and context mapping. Our goal with this process is to identify the core domain and the subdomains, and to define the bounded contexts and the context maps in our system. To express the domain model in our code, we typically follow the tactical design process that uses a set of building blocks to construct the domain model. These are entities, value objects, aggregates, repositories, services, factories, and domain events. Let's take a look at each of these building blocks in more detail. Entities are objects that have a unique identifier and a life cycle. They are mutable and can be modified over time. Entities have a conceptual identity, meaning that even if their attributes change, they are still the same entity. Also, entities are not equal to each other even if they have the same attributes. For example, an alarm with the same name and severity is still not the same alarm. It's a different alarm entity with the same attributes. Value objects, on the other hand, are immutable and don't have a unique identifier. They are equal to each other if they have the same attributes. In our system, we used value objects to represent the severity of an alarm. Aggregates are a cluster of objects that are treated as a single unit. They ensure that all the objects within the aggregate are always in a valid and consistent state. An aggregate represents a transactional consistency boundary, meaning that changes to the objects within the aggregate should be made in a single transaction. In other words, any modifications to the state of one entity within the aggregate should be done within the context of the aggregate itself. Repositories are used to persist and retrieve aggregates. They provide an abstraction over the data access layer and allow us to work with aggregates without having to worry about the underlying data access implementation. We actually already used repositories in our application to persist and retrieve alarms. Services are used to encapsulate domain logic that doesn't belong to any particular entity or value object. For example, we can have a service that is responsible for sending notifications to the users when a new alarm is created. We must be careful when using services because the heavy use of services can be a sign of an anemic domain model. An anemic domain model is an anti-pattern where the domain model doesn't contain any domain logic and is essentially just a bunch of getters and setters. Factories are used to encapsulate the creation of complex objects. They are particularly useful in scenarios where the creation of objects involves complex validation, initialization, or the coordination of multiple steps. Factories help us to keep the domain model clean and focused on business logic while offloading the responsibility of object creation to dedicated factory classes. And lastly, we have events, which are used to communicate and capture domain-specific information about actions or domain model changes that have happened in the past. Events play a crucial role in enabling loose coupling, scalability, and eventual consistency in distributed systems. We distinguish two types of events: domain events and integration events. We'll talk more about events in future lessons. So we've covered quite a lot of broad concepts here, but to recap, DDD is not a technology or a methodology. It's essentially a set of principles and patterns that can be applied to any software project. It's also not a silver bullet. It's not going to solve all of our problems, but it can help us build better software and tackle the complexity of some of our projects. As we mentioned above, we actually already applied some of these concepts in previous lessons, and we'll continue to implement and learn more about all of them as we build out our applications throughout the rest of this course.